Lecture number 4, Exposure. We're going to talk about the human eye and camera and how they work and how they are different. The basic fundamentals of a camera and the human eye are exactly the same. The light comes in through the lens of the eye and it's projected onto the optic nerve at the back of the eye, and the information that is received there is reversed upside down to right side up and corrected left to right. Same thing happens in your camera, but instead it is captured upside down and backwards, but displayed in the viewfinder and on the back of the camera correct. What the human eye and what the camera captures are identical. Is this a true or a false statement? It is a false statement. Our eyes are both our best friends and our worst enemy. The eye is correct for whatever situation we find ourselves in, and the camera is not capable of doing that. We need to take charge of the camera and direct it to copy and capture what we want it to do. As we see it, our eyes and brain work together to recall what we see at the center of our vision. What we really see is what our mind reconstruction of the objects based on the input provided by our eyes, not the actual light received by our eyes. The current digital camera can capture somewhere between 5 and 30 megapixels. The human eye can capture up to 52 megapixels worth of information. Here's an illustration showing how our eyes work together and what we can see. We have binocular vision, and that allows us to overlap and to get three-dimensional vision. We can see depth. Our camera is monocular. It only captures in 2 dimensions, height and width. Not like the human eye, which can see depth. Our eyes only see and recognize detail at the center 20% of the image. The rest of it is blurred. And it is there, and we recognize it, but we can't see the detail in it. Our mental image is prioritized based on our interest in what we see. We see what is important to us, but not the other things in any detail. Talking about detail, the way that we measure detail is what's called line pairs. Resolution is measured in the number of line pairs in a given area. It varies up to 400 line pairs so that you can see the detail and to have the resolution. Resolution is not just the megapixels, the number of megapixels that we capture to get the detail and get the resolution that we want. It's also the product of the total camera system, hardware, camera body, lens, and software. Here's an illustration showing different resolutions. You need more and more megapixels to get more and more detail. The greater the resolution, the more detail you have in the pictures. What is ISO and ASA? ISO and ASA are International Standards Organization and American Standards Organization. They use the same numbers for both of these identifiers. It's just a contest between the United States and the rest of the world to have their little mark on how we measure the sensitivity of what we're taking pictures of. EV is the result of a test for the best exposure on a sunny day. Back in the good old days when we started doing this, what we did was we set up a camera with a brand new roll of film in it and took pictures. We set the camera at f/16 and ran from the slowest shutter speed to the fastest shutter speed, and then determined what the best exposure was to get the results that we wanted. And then we would figure that, and we would use that number as the ASA or ISO. Basic rule today in a good old day is to use, if you have an ISO of 100, you set your shutter speed at 1/100th of a second at f/16, and that's a starting point for making exposures. focus, audio or manual. As photographers, you are responsible to make sure that what you're taking a picture of is in focus. Most of the time, autofocus is the right choice. It's very good. Autofocus is the correct choice most of the time. You must constantly check to ensure that the subject and the background are both in proper focus, as you wish. Autofocus examples. In fast-moving environments, surveillance, riots, you need autofocus. Things change and your subject matter changes from being close to being distant. When it's a dynamically changing environment, this is the way to go. Here's an example of autofocus. The lens focuses and then you push down on the shutter release and you capture image and you get the stop action of what you want in sharp focus. Manual focus is the best choice for taking pictures of impression of evidence, such as blood spatter, tool marks, and fingerprints. When you are capturing a difficult object, be careful with your lighting and your focus. Here is a picture that I captured for illustration purposes of a firing pin and the impression of the firing pin in the primer of this expended cartridge. The cartridge and the scale are both in focus. The exposure triangle. This is a very important piece of information that you need to understand and appreciate. You have to make decisions. What is the most important thing when you're making an exposure? The variables in exposure are time, intensity, and ISO. Time times intensity times ISO equals exposure. Time is the shutter speed that you choose to capture your image at. Intensity is the opening or aperture that you choose to use to capture the image. And ISO or ASA is the sensitivity. The aperture is based on human eye iris. It opens and closes depending on the amount of light in the environment that you are capturing your image at. Your iris opens and closes. Here's an example of an iris or an aperture in a lens. You can see that it has little leaves of metal and it opens and closes so that you can adjust the amount of light coming through the lens. Here's an illustration showing how you can get the same exposure using a different combination of shutter speeds and apertures. At 1/1000th of a second, your lens has to be very wide open so that you get a lot of light to come through the lens in a very short period of time. At 1/60th of a second, you have a slow shutter speed and a small opening so that you can control the amount of light coming through the lens. The same exposure can be produced using different shutter speeds and aperture combinations. At 1/1000th of a second, a very high shutter speed and a very large opening, you get a lot of light coming through the lens in a very short period of time. At 1/60th of a second, you have a slow shutter speed and a small opening, but they both produce the same resulting exposure. Here's an illustration showing making a choice on what is important in your image. Here's a pinwheel and a fan, and showing you how choosing the shutter speed makes a big difference in the final result of the image that you've taken a picture of. At 1/200th of a second, you can stop the motion of the pinwheel. At 1/125th of a second, you get some motion, but you can still see it's a pinwheel. At 1/60th of a second, this pinwheel is just a blur. Digital noise. Digital noise is a product of the ISO that you've chosen to capture your image. The higher the ISO, the less quality resulting image you will get. The amount of digital noise that you get is a product of the size of the sensor and the number of megapixels your camera uses to capture the image. Here's an illustration showing the differences between 100 and 3200 ISO. The 100 ISO, you get little or no digital noise. Back in the old days of film, we would call this grain. We had to use film that had more grain in it so that you could take pictures at low light level conditions. Here we've got good conditions. Our camera's on a tripod, and we can have a slow shutter speed and a slow ISO or sensitivity, so we get excellent detail. As we move up the ISO, the quality of the image gets poorer and poorer. The grain or pixels in the image become more and more obvious. When you change one of the variables, shutter speed, f-stop, or ISO sensitivity, what do you have to do to get the proper exposure? When you change one of the variables in the exposure triangle, you must make an equal and opposite change to one of the other variables to produce a correct exposure. Exposure determines the brightness or darkness of your final image. The correct combination of aperture, shutter speed, and sensitivity can produce varied results in the final product. You have to make this decision as to what you think is important and what you want to capture in the image. This is an example showing how you have a situation where the background is fully lit in sunlight and the foreground is in the shade. So we're taking a picture. So here with a combination of the two, and you have to make choices. The background is properly lit here, and the foreground is underexposed. In the lower left, the foreground is properly exposed, and the background is overexposed. And here we have more detail in the lower right. We get more detail in the background, and the foreground is very dark and you can't see. One of the ways to solve this problem is to use what's called fill-in flash, so that you can balance the light in the foreground using a flash so it equals the same light level as is in the background. This gets a well-balanced photograph. It looks like they're both evenly lit. Why do we choose different f-stops and or shutter speeds to achieve the same exposure? We need different results. If you want to stop action, then you need a high shutter speed to stop the action in the image. When you do that, you have to change the other things to balance out the proper exposure. How does an aperture of f11 or higher affect your image? f11 or higher means that you have a lot of depth of field. The foreground and background objects are both in focus, but the other objects in the image, if they're moving, might be blurred. How or why is a lens fast? A lens is fast first because it allows a lot of light to pass through the lens barrel, much more than other lenses. And why is this important? Because you want to stop the action. So this means that you've got a very large aperture and a high shutter speed so that we can stop action. If you're out there and a sports photographer taking pictures at some type of a event, football, basketball, baseball game, you want a high shutter speed and you will give up depth of field, and that's what the results that you get. Here's an illustration showing the different choices and what we do. Why do we need exposure choices? Well, here, this photograph illustrates using a fast lens. The young woman picture here is in focus. The foreground's out of focus and the background is out of focus. Only she is in focus. This is a very short depth of field. The other picture is on the bottom, and nothing is moving very quickly here, and we want to get the foreground and the background in focus. So this is a long exposure at a small aperture so that we can achieve this. Again, here's an illustration showing a fast lens, high shutter speed, very short depth of field. The subject and only the subject is in focus. The foreground and background are not in focus. This also creates the illusion of 3 dimensions. It gives the foreground is in focus, The background is out of focus, so it makes things look sharper, and it gives you an illusion of 3D. Here, this is a slow shutter speed. The clouds and the mountains are staying right where they are. They're not moving, and the water is moving, and you want to use a slow shutter speed so that you get the movement of the water. You don't want to stop the water. You want it to be moving so it illustrates and gives you the illusion that this is a picture showing this water flowing. If you shoot this at a high shutter speed, it stops the water and it doesn't give you the effect that you want. Aperture controls your depth of field. These numbers are inverse. The smaller the number, the bigger the opening. A 2.8 aperture means that you have a very small depth of field. You are focused on your object, and your object is in focus, and the foreground and background are out of focus. At f22, your foreground and your background are both in focus, and if you've got something like the picture I just showed you, where the water is moving, you want that water moving, and the mountains are moving, and it illustrates that the water is moving. Again, this is depth of field, large depth of field. If you have a large depth of field, you focus on an object that's 1/3 of the way into what you're taking a picture of, and it's the object to beyond it are in focus also. When you have a very shallow depth of field, the object that you are focused on is in focus, and everything in front of it and in back of it are out of focus. Here's an illustration of short depth of field. Thistle here, I took this picture, and the foreground and the background are out of focus. You have a very short depth of field, and only the thistle is in focus. And then on the other illustration, this jet is sitting here, and you've got from the tip of the nose of the jet to the horizon, everything is in focus. You have a large depth of field, and you can get everything in focus this way. Short depth of field. Again, this illustrates very high shutter speed, very large opening, and you stop the action, and you're in focus. You focus only on the object you're capturing a picture of. This is another illustration of the same thing. This is a crime scene illustration showing how depth of field can be a real benefit for you. This is a fake bullet hole in a piece of glass at my home. I took this picture. The picture on the left, I took it with a very long depth of field, and you can see that the screen in the background and the fake bullet hole are both in focus, and it's very hard to see the fracture marks in the glass because they compete with each other. And the picture on the right, I opened up the aperture and I separated the bullet hole from the background, and so the background is out of focus and the bullet hole is in focus. This is another illustration of depth of field. This is another bullet hole and piece of glass on the left. I've got the bullet hole in focus here and the background out of focus. On the right, you have the bullet hole in focus and the background in focus, and it's hard to separate the two. This is a wonderful illustration, not by me. I used this with this illustration provided by someone else. This is f5.6 versus f22. The f5.6, the young woman's head is in focus and the fence is out of focus. And the bottom, you've got the foreground and the background in focus. They compete with each other. They don't, it's a wonderful illustration showing how depth of field can be your friend or your enemy, and how to wisely choose what f-stop you want to use to capture your image. Here, depth of field. This was a small a mock-up at one of our forensics conferences. Here on the lower left, you can see that the little mock-up crime scene is shown on the back of the camera. The back of the camera is in focus, but the crime scene is out of focus. The center one, the crime scene is in focus, and the display on the camera is out of focus. And on the far right, both the mock crime scene and the image on the back of the camera are in focus, because I took it with a small aperture and a long exposure. Long depth of field, foreground and background are in focus. This is a helpful hint. When you're taking pictures of something moving in front of you, you don't want the object directly in front of you. It comes and goes very quickly and makes it very difficult to capture an image. If at all possible, you should try to get diagonal, and so that the object that you're taking a picture of is in your line of sight for a longer time. This is the way to take pictures of something that is passing in front of you that you need to capture an image of. You pan with the object. You don't try to stop with, you move with it so that you can get a picture. And this is one of the solutions. This is a picture that I took at the Prescott Rodeo one time, and I tried to pan with the rodeo riders trying to rope this cattle here. And here again is picture showing 1/200th. You stop this pair in air, and it's just floating in the air. The next picture is 1/15th of a second. You can see it's moving during the exposure in 1/15th. And the pouring of the glass of wine on the left, you have a slow exposure, so you can see the wine flowing into the glass. And the picture on the right is a fast exposure, and it looks like it's dripping. It's not very good. It doesn't tell the story. Here are some other illustrations of using a slower shutter speed for effect to get the results that you want. These are very slow shutter speeds. The upper right, you're panning with the little girl on the rope swinging, and she's in focus, and the background is out of focus. It's a very good illustration showing motion. And the lower left, you get the car moving through. It's blurred, but you can see what it's doing. So here's our illustrations. Which one of these is which? Which one is, you've got the water flowing on the upper left, and on the right, you've got the play at home plate. Which shutter speed do you use for which? Upper left is a long exposure with a small opening, getting the flowing water so that it looks very pretty. And the lower right, you want to stop the action, so you get a very high shutter speed with a large aperture. Here again, the water is flowing, and it works very well. And then we've got this illustration of this man on this bicycle, but you're wondering, how is this man pedaling this bicycle when he doesn't have legs? Well, he does have legs, but now you have chosen to take a picture at a slow shutter speed, and the legs don't stay in one place long enough to be captured by the camera on the light-sensitive material. Flash versus variable light documentation. This is an illustration showing how effective or ineffective your flash is. Your flash carries a maximum of about 10 feet out in front of your camera. Here on the right, lower right, is a picture of taking available light pictures with long exposures. Here's another illustration of the same thing. You can see that your flash only carries about 10 feet. The one on the lower right is a long exposure, multiple seconds, using the light available at the scene. It works very well. And here, I didn't play fair. This was a full moon this night, and so I've got the full moon up there in the sky. And if you look just above the trees on the left side of this picture, you can see there's a plane coming in to land at Sky Harbor, a little line of white, and this is all taken by available light. And on the right is a picture taken using flash, and the flash only covers a very small area and falls off very quickly, and you can't see down the street. This is a wonderful example of the inverse square law in action. You can see where on the right the flash only carries to a maximum of 10 feet or so. On the left, you recognize that you've got light up and down the entire street, and you use the light that's available to you there in this lighting situation to produce a realistic picture. High dynamic range. This is using the computer to produce an image beyond the ability of your camera to capture these images. You take multiple images. Here is a straight photograph of this burned out building. You can get one or the other, but you can't get all of it in a single frame with one exposure. Here, this is the same scene, but we have multiple exposures, and we overlap them and adjust them and then put them together to create this one image that uses this high dynamic range editing technique. I want to say a special thanks to King Brown, Don Watkins, and Bob Carruthers for their help in doing this presentation. Do you have any questions?